Hello friends, welcome to my channel. Let's have a look at problem 2489 again, number of substrings with fixed ratio. So this is the second video for this problem. So in this video, we are going to share a solution based on using invariant quantity. First, I'll quickly read through the problem statement and then explain the method, and finally we share the code. First, the statement. We are given a binary string S and two integers n1 and n2. So n1 and n2 are co-prime numbers. So a ratio substring is a substring of S where the ratio between the number of zeros and the number of ones in the substring is exactly n1 over n2. So we are required to return the number of non-empty ratio substrings of S. So before we do the analysis, let's remark that S is not empty and both num1 and num2 are positive, right? So with that said, we are ready to do the analysis. So here, we want to count the substrings. So for that purpose, let's first define a function f. So fi is defined as the number of zeros for the substring starting from the beginning index 0 and ending at index I. So we are going to consider the substring starting from index I plus 1 and ending at j, right? So the requirement number of zeros in this substring over the number of ones equals to num1 over num2 is equivalent to this format. The number of zeros over the number of zeros plus number of ones equal to num1 over num1 plus num2, right? You just add the numerator to the denominator. So this is equivalent mathematically. And then actually the number of zeros in the subarray is nothing but fg minus fi. So this fg minus fi is the number of zeros in the substring starting from index I plus 1 and ending at index j. So j minus I will be the length of this substring. And then this should equal to n1 over n1 plus n2. Then if we do cross multiplication, so we have fg minus fi times the denominator n1 plus n2, then equals j minus I times n1. Then we want to do some transformations to make I and j decouple. So if you do the math, so you get fg times the sum of the two numbers n1 and n2, then minus n1 times j. So this part contains only the index j. So it equals fi times n1 plus n2 minus n1 times I. So this contains only index I. So in other words, so this format f ending at index times the sum and minus n1 times the index. So this is a fixed quantity. So we see that mathematically it's an invariant. So notice that the decoupling property in star is crucial for this method. So as we noticed this point, so we just need to find the frequencies of such quantities. So fi times n1 plus n2 minus n1 times I when we linearly scan the string, right? So here is a note. So this actually can be important. So star actually applies to substrings starting from index I plus 1 up to j. In other words, the starting index is at least 1, right? Because I is greater than or equal to 0. So to include the substrings that starting from 0 index, from 0 and ending at I, we just need to check the condition during the linear scan. So fi, so this is the number of zeros in the substring starting from index 0 and ending at index I, then divided by the length, which equals to n1 divided by n1 plus n2. So notice that we are dealing with integers, so we can do a equivalent transformation mathematically. This format is nothing but fi times n1 plus n2 equals I plus 1, the length times n1. So this format is a little bit different than the format or the invariant in star. But this is a format for substrings starting from index 0 and ending at some generic index. So with that said, so actually together the star and these two invariants, so this is one for a generic index and this is one for a generic index. So together this forms the format 2 of the solutions. So if we have grasped the idea, so solving this problem is actually a straightforward thing. So with that said, let's do the coding. So here I'm going to use the default dictionary, collections default dictionary. So this is a subclass of the vanilla dictionary of Python abstract data type. So then we're going to counting. So we want to a key has a default counting 0. And then we're going to initialize a result variable. So for the counting, then the number of zeros will be the genuine the number of zeros. So it's slightly different from the solution 1, right? In solution 1, we do a weighted counting. So then we just need to iterate over the string s. So because we are going to use the index information, so we are going to use the enumerate function for I and the character in enumerate s. Then what we are going to do is that, so we want to count the number of zeros. So we want to add, so if we want to add 1 or not, depending on if the character equals 0, right? So once we do this, then we want to check this quantity, right? So we're going to check. So if n zeros times num1 plus num2 equals the length I plus 1 times num1. So if this is the case, so we're going to add 1 to the result. So this line of code actually considers the substrings starting from index 0 and ending at a generic index I here. So this is one consideration. So another invariant actually is nothing but num1 plus num2 times the number of zeros. So that is fi, right? And this is n zeros. Then minus n1 num1 times I, right? So we're going to add this count increment by 1, right? So once we finish this for loop, so notice that by far we only count the substrings starting from index 0 and ending at a generic index I. We need also to count those actually starting from I plus 1. In other words, at least index 1. So for this, we just need to count for value or frequency in d values. So we want to, for example, if the frequency is 3, we just need to choose 2 indices as the start point and end point of the corresponding substring. That counts 1. So this corresponds to choose 2 out of v, right? So in particular, if v equals 1 or 0, so then the formula will give us 0. So we are going to compute v times v minus 1, then integer division by 2. So if v equals 0 or v equals 1, so we do nothing actually. Or if you like, you can use if v is greater than 1, then we do this. But it's not necessary. So then I just need to directly do this. So notice that this number is always an even number because v and v minus 1, at least one of them is exactly, actually one of them is even, right? So you can integer division by 2 without a non-zero remainder. So with that said, we finished all the counting. Then we just return the final state of this result variable. So with that said, we are ready to do a check. So local variable n0s referred before n0s. So here it's a typo. So n0s. Let's check again. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the generic cases. So with this test done, so this finishes the second solution format for this problem. So I would encourage you to check out the previous video for the dictionary and check solution. So actually for this kind of problems, we have practiced quite a lot in our channel. So you are welcome to check out the relevant videos. So with that said, I guess that's about it for this second video. Thank you.